Hi, I'm DJ Musoff.
Hello, my name is Sevi Malcolm.
My name is Dan Hopkins.
My name is Robert Lind, and these are the tomato garden tending robots.
Our problem statement describes how maintaining a garden can be very involved, so an automated system can help someone manage and sustain a garden more easily. This automated system would be most helpful toward newer gardeners who want to grow tomatoes. The issues that our product would solve include problems with watering, ensuring tomatoes are ripe, keeping a balanced pH, and preventing unwanted pests. Therefore, our solutions involve automatic watering, ripeness detecting, pH monitoring, and predator deterrent. Our proposed robots include a watering robot, a ripeness robot, a fertilizer robot, and an anti-squirrel robot. The first robot is a watering system attached to a hose that can be activated in two different ways. First, if the button on the system is pushed, the watering system will activate by servo motor for 30 seconds while spinning 180 degrees to cover the entire garden. The second way is initiated when the moisture sensor reads a value under 60%, which proceeds to water until the moisture in the soil is up to 80%. The system then shuts off and waits to read a value under 60% or be activated by the button.
The ripeness robot is a system that will detect the red color of a ripe tomato. The photoresistor will be used, so the system only runs in the daytime. The system uses the stepper motor to run the color sensor up and down daily to scan the entire height of the tomato plant. If the red and ripe tomato is detected, the servo will be triggered to raise a little flag from horizontal to the vertical to signal that there is a ripe tomato in the bunch. Once night approaches, the photoresistor will trigger the flag to reset to the down position.
The fertilizer robot uses a soil pH sensor and two servo motors to tell the gardener what the pH levels are for the soil. If the soil is lower than 6 or higher than 7 for their pH value, a flag will go up to tell the gardener that the pH is out of range.
I'm presenting the squirrel deterrent robot, or the anti-squirrel robot. It allows the gardener to reap the benefits of the other three robots and consists of an Arduino Uno, a PIR motion detector, a photoresistor to determine if it is day or night, a bright LED that will flash if it's night and motion is detected, a DC motor driven by an H-bridge motor driver for the reflective flap wheel, and a servo that oscillates the main body, including the reflective flap wheel.
Here's our tomato garden system. The bots have limited user interaction and they all operate completely independent of each other. The bots themselves don't move throughout the garden, but each has several moving components. The watering bot has a servo-driven flap that opens and closes to allow water to flow out of the nozzle. The base assembly is also servo-driven that allows the assembly to pivot that can coat the entire garden with water. The ripeness bot has a stepper-driven belt that moves this gantry up and down very similar to a 3D printer track. When ripeness is detected via the color sensor, the indicator flag, which is also servo-driven, will pop up to indicate that a ripe tomato is found. The fertilizer bot also has a servo-driven wheel that's used to indicate the level of pH of the soil. If the soil is out of spec, then a similar indicator flag is used and it will be raised or lowered in the assembly. Lastly is the anti-squirrel robot. When motion is detected, the DC motor spins the reflective flaps to scare away the squirrels. Also, the base is servo-driven, so the entire assembly will sweep side to side while rotating to add extra motion and a little extra scare to those critters.
Benchmarks and value added. Watering bulbs on the top left need their straws cleaned out periodically. They don't actually measure how much moisture needs to be added to the soil, they just continue to add as long as they have water. The tomato picker robot and fertilizer robot at the top right and bottom left are both used for larger industries. but they're not really suitable for smaller non-industrial gardens. The animal scaring robot on the bottom right has poor reviews on Amazon, and the frequency it puts out doesn't actually scare the animal, and it's audible to people as well, and no lights or any physical flapping or anything that would actually scare animals.
In conclusion, this project allowed our team to explore new skills like programming and CAD designing. It enables the team to learn some about tomato gardening because not all of us garden, and the team had to learn how to adapt and communicate with those in completely different time zones with completely different schedules in their life.